The man who predicted black holes spent years trying to prove they were impossible. Albert Einstein, the same guy whose equations literally created the concept, published a whole paper arguing they couldn't exist. He was wrong, obviously. But the story of how we got from "this is nonsense" to actually photographing one of these things, it's wilder than you think. And later in this video, I am going to tell you about a black hole that is eating so fast it breaks the laws of physics. At least, the laws as we understand them.
Okay, so first, what even is a black hole? Simple version, it's a point in space so insanely dense that gravity just wins. Nothing gets out. Not matter, not light, not even information. You cross a boundary called the event horizon, and that's it. You're done. Gone. One physicist called it a perfect one-way door. Things go in, nothing comes back. And here's something that still messes with my head. Every black hole in the universe, every single one, can be fully described by just three things: mass, spin, electric charge. That's it. You could throw a piano, a spaceship, and every book ever written into a black hole. And once it crosses that threshold, all that's left is three numbers. The universe doesn't care what you were. It just takes your mass and moves on. Now, let me rewind, because the origin story here is genuinely bizarre. Einstein drops general relativity, completely rewrites how we think about gravity. Within months, a German soldier named Karl Schwarzschild, sitting in the trenches of World War I, solves Einstein's equations for a single, non-rotating mass. And what falls out of the math is horrifying. A point where gravity goes infinite, where space-time folds in on itself so hard that nothing escapes. Schwarzschild mailed his solution to Einstein from the battlefield. He died the next year at 42, never knew what he'd started. Einstein read it and basically said, nah. In 1939, he published a paper trying to kill the whole idea, called it not convincing. But that same year, Robert Oppenheimer and a student named Hartland Snyder published their own paper that said, sorry, the math works. Stars can collapse. These things can form. And the modern concept was born. The name black hole didn't show up until 1967 when John Wheeler coined it. Before that, people called them frozen stars, which, I mean, not exactly catchy. So let's talk sizes, because black holes come in flavors and the range is absurd. Stellar mass black holes are the most common. A big star runs out of fuel, collapses, boom, black hole. 3 to 50 times the mass of our sun, and our galaxy alone might have 100 million of them, just floating around in the dark. Sleep well tonight. Then you've got the supermassive ones, hundreds of thousands to billions of solar masses. The one at the center of our galaxy, Sagittarius A star, is about 4 million solar masses. Sounds big, right? The one in galaxy M87 is 6.5 billion. Its event horizon stretches 40 billion kilometers. And then there's the black hole at the center of Holmberg 15A, 40 billion solar masses. I can't even pretend to visualize that. Nobody can. Now, here's a gap that drives astrophysicists crazy. And I teased something weird earlier, so hold that thought for a second. Between the small ones and the monsters, there should be medium-sized black holes. Intermediate mass, 100 to a few 100,000 solar masses. Logically, they should exist. Collisions over billions of years should have built them up. But for decades, nobody could find any. That gap is still one of the biggest unsolved puzzles in the field. There might also be primordial black holes, formed not from dying stars, but from the raw chaos of the Big Bang. We haven't found those either. Yet. Okay, quick detour into nightmare fuel. What happens if you actually fall into one? You get spaghettified. That's the real term. Tidal forces stretch you into a long, thin noodle because gravity pulls harder on whatever part of you is closer. For a small black hole, this starts before you even reach the event horizon. For a supermassive one, and this is the creepy part, you might cross the event horizon without feeling anything. And then the stretching begins.
And honestly, if you're vibing with this so far, do me a favor. Hit subscribe so more stuff like this shows up in your feed. It takes 1 second and it genuinely helps. Cool? Cool. Back to it.
Now, Hawking radiation. This might be the most brain-breaking idea in all of physics. In 1974, Stephen Hawking showed that black holes aren't actually black. They give off a faint glow, and over absolutely insane timescales, they slowly evaporate. How slow? A solar mass black hole would take 10 to the power of 67 years to disappear. The universe is 14 billion years old. We're not even in the same zip code. A supermassive one? 10 to the power of 100 years, numbers that make eternity look short. And that popular explanation you've probably heard, virtual particles popping up at the edge of the event horizon? Yeah, that's actually wrong. The real mechanism is about space-time curvature itself slowly bleeding energy away. In 2023, researchers showed this effect isn't even unique to black holes. All massive objects do it. Hawking got the big picture right. The details? Not quite. Which brings us to the information paradox. 50 years of theoretical physics consumed by one question. If a black hole evaporates completely, where does all the information go? Everything that ever fell in, what happened to it? Quantum mechanics says information can't be destroyed. Hawking radiation seems to say it can. Recent work on something called the island formula suggests that information does get out, encoded in the radiation in ways we're barely starting to decode. Now, remember that thing I said I'd come back to? Here it is. In 2024, astronomers found a black hole called LID 568 feeding at 40 times its theoretical maximum rate. 40 times what physics says should be possible. And in 2025, the James Webb Space Telescope confirmed a supermassive black hole that existed just 570 million years after the Big Bang, growing way faster than any of our models predict. We also found a million solar mass black hole just wandering thousands of light years from its galaxy's center, ripping apart stars in the outskirts like some kind of cosmic stray dog. AI analysis of 12 million simulations revealed Sagittarius A star, our black hole, is spinning near its maximum possible speed. We've detected around 300 black hole mergers through gravitational waves. The Event Horizon Telescope collaboration now spans over 60 institutions across 20-plus countries. We went from Einstein saying, "This is ridiculous," to photographing these things and listening to them crash into each other in real time. But here's the thing, for everything we've figured out, black holes still keep their deepest secrets locked behind that one-way door. What's actually inside the event horizon? What sits at the singularity? Is it really a point of infinite density? Or does some physics we haven't discovered yet step in? Arthur Eddington once said, there should be a law of nature to stop stars from doing something this absurd. Turns out, nature had other plans.
And if that messed with your head, wait until you see our other videos. Thank you for watching.